Welcome back to Miss Eddie's Math Movies, where it's a cute to be a square. Today's lesson is 10.6, Solving Right Triangles. By the end of the lesson, you'll be able to solve a right triangle. To solve a right triangle means to find all the angles and all the sides. All the missing angles and sides. So we've been doing a lot of working with sides, but we haven't done a lot of finding angles. So that's what we're going to use here. These are used only to find angles. The inverse tangent, the inverse sine, and the inverse cosine. Inverse tangent looks like this. It's tan the -1. So on your calculator, you're going to press second tangent. And this is to find the angle. Find angles. This is all we use inverse for, is to find the angles. Inverse sine. You're going to press second sine. And inverse cosine. I guess your second part looks like this, doesn't it? Second cosine on your calculator. Let's talk about how we're going to do that. So in this case, the angle is going to be what's missing. So we need to get A all by itself. So we have to undo tangent. Just like adding and subtracting undo each other, multiplying and dividing undo each other. If you want to undo a square, square, you take the square root. To undo tangent, you have to inverse tangent. So I'm going to take the inverse of this side and the inverse of that side. So tangent and tan inverse are going to cancel, and you're just going to be left with angle A. Same thing here. If I want to get angle A by itself, I've got to take the sine inverse of this side, and I have to do it to both sides because this is an equation. That's how I'm going to get A all by itself. How am I going to get A by itself here? I've got to inverse cosine. So the opposite of sine is sine inverse. To undo cosine, cosine inverse. That's how I'm going to be left with just A if I take the cosine inverse of both sides. So let's apply this. Let's figure out what I'm actually talking about here. Let's do an example. Use inverse tangent. Okay, it says find the measure of angle A. So I'm standing at angle A because I always have to stand in angles. And I need to find that angle. So I'm going to use the inverse. Well, what inverse am I going to use? Well, let's look at what did they give me? They gave me the opposite and they gave me the adjacent. So remember SOHCAHTOA. SOHCAHTOA. Which one do I want to use? Well, opposite and adjacent. That's tangent, opposite and adjacent. So I'm going to write tangent. And always here I write where I'm standing, which I'm standing at A. So the tangent of A is opposite over adjacent. Now notice this is different than what we did before because now our variable's here. Normally our variable's over here. I want to get A all by itself. I have to get rid of tangent. And we just learned to get rid of tangent, you take the inverse. So if I'm going to tan inverse this side, I have to tan inverse this side as well. So now what's left? Well, these two cancel out. So I'm left with A equals. Now this is what goes in my calculator. So like I said, you're going to use the second tangent button. So here's my calculator. Here's second. There's tangent. See, tan inverse is right there. So second tangent. So there's my tan inverse. And I want to take the inverse of 8 over 10. So 8 divided by 10. Close that parenthesis. 38.7 degrees. We're not going to worry about that follow-up. Solve the right triangle. Find the measure. Okay, so remember, solving means find everything that's missing. So I need to find little c, and I need to find angle A and angle B. Well, we know how to find c. Look, they gave me two sides. I can use the Pythagorean theorem. A squared plus b squared equals c squared. So a squared plus b squared equals c squared. So that's 4 plus 9 is 13. C squared equals 13. Take the square root of both sides, and we could just leave it as c equals the square root of 13. I would like to leave it in square root form, but if you want to put it as a decimal, 3.6. Let's put that back in our picture. So now we need to find the angle. So they want us to find angle B first. Let's stand over here in angle B. And I could use sine, cosine, or tangent because look at, I have everything. But I'll just use what they gave me. They gave me the opposite and they gave me the adjacent, right? This is the hypotenuse over here. This is the opposite, this is the adjacent. So they gave me the opposite and the adjacent, which is tangent again. So I'm going to use tangent, and I'm going to have to use the inverse because I'm looking for the angle. So I'm going to start with tangent. Where am I standing? Standing at B equals opposite, which is 2, over adjacent, which is 3. Once again, my variable's here now because I'm looking for the angle. I need to get rid of tangent. So I take the inverse of both sides. These cancel, and I'm left with B equals second tangent. This is when I'm solving for angles. 2 divided by 3. 33.7 degrees. Now I should find angle A. Well, if I know B is 33.7, I know there's 180 degrees in this triangle. So I'm going to do 180 minus 90 minus 33.7. Angle A is going to be 56.3 degrees. So I found A and B, and I found little c, which was a side. All right, we're going to do these now. I'm going to do one with you from each section, then you're going to do them on your own. Find angle A. Well, I'm trying to get A by itself, so I have to get rid of tangent. To get rid of tangent, I take the inverse of this side, and I have to do it to both sides. A is equal to second tangent, and then I put in 3.5. There you go. 74.1 degrees. All right, so I want you to do these now. Make sure that your calculator's in degrees. If you're not getting the same answer, press mode and check to make sure that your calculator says degree. So you're finishing those, all right. Here we've got to find, just the measure of angle A. So I'm standing at A, and they gave me the opposite and they gave me the adjacent. So I'm going to use tangent. That's opposite and adjacent. I'm standing at A, opposite, adjacent. I have to get rid of tangent. A is equal to, because these are going to cancel, the inverse tangent of 5 divided by 9. 29.1 degrees. Please go ahead and do those now. Now here, we have to find angle A. We have to get rid of sine. To get rid of sine, we use sine inverse. Have to do it to both sides. The sines, inverse and regular sine, are going to cancel. and A is equal to, now we're going to press second sign and put in 0.55, 33.4 degrees. In example B, we have to get rid of cosine, so we use cosine inverse. Since I want to get A out by itself, these cancel. A is equal to the inverse cosine of 0.48, 61.3 degrees. Find each measure. It looks like we're solving this whole right triangle. Well, so they want us to find angle G first. So let's stand here at angle G. Remember, to find angles, we have to use the inverse. But what inverse are we going to use? Let's look what they gave us. They didn't give us the opposite. They gave us the hypotenuse and they gave us the adjacent. Well, think about SOHCAHTOA. Adjacent and hypotenuse. Oh, that's cosine. So I'm going to write cosine. Where am I standing? G. And cosine is adjacent over hypotenuse. To get rid of cosine, I have to do the inverse. And G is equal to the inverse cosine of 16 over 25. G is 50.2 degrees. Now to find H isn't too hard to find because I know there's 180 degrees in a triangle. So 180 minus 90 minus, I already have 50.2. I need 39.8 more degrees in my triangle. I need to find little g still. Well, I can use regular SOHCAHTOA if I want, but notice I already have two sides, so I can just use the Pythagorean Theorem. That's another way. So here's these two answers. G squared plus 16 squared equals 25 squared. I believe that's 256. I think that's 525. Oh, 625. Take the square root. Oh, it ends up being a decimal. Can we use decimals? Yep, so it's round to the nearest tenth, so we don't have to break that down. Little g is 19.2. So that's one way you could find little g. Or, if you like using SOHCAHTOA, since we have this angle, we could use opposite over hypotenuse, which is sine. So I could say sine of 50.2 equals the opposite over the hypotenuse. Look at that. 25. We're not using inverse now, just regular. Sine of 50.2. Look, 19.2 gives you the exact same thing. So you can use the Pythagorean Theorem or regular trig. Use a calculator to find the measure of angle A. This is just like example 3. Go ahead and do this now. Solve the right triangle. All right, so you're going to have to show your work down here. We need you to find angle A, angle B, and X. Angle E, angle D, and Y. Angle H, angle G, and Z. So you can do the Pythagorean Theorem for these if you want. You already know how to do that. And then use the inverse. This is M cubed, signing out.